Yes, good evening.
Yes, sir.
Yes. Morning, you understood the radix sort. Uh, and what is the other one that you understood? That is the only thing I think. Radix sort you understood, yes or no?
Yes, sir.
Okay. Now the next sorting technique is address calculation sort. Okay. And you can go for considering this as the fastest type of sorting technique if you have the enough space. Because why we say enough space is because you have to go for building the linked list. In the morning also I mentioned. So all the earlier sorting techniques we use them as by using the arrays, but for this you got to make use of the linked list. Why? I'll tell you. So that is the reason it says if enough space is available for you to create the multiple lists, so then you can go for using the address calculations sort, and is also considered as the most fastest type of sorting. Okay. And also called as hashing. This also uses the concept of hash table. Now, what is an hash table is? An hash table is something like which stores the key value pairs. So every value has some unique key, and using that unique key you can go for searching the value. And this is much faster because searching based on the key is much faster than performing the normal sequential search. So in this algorithm, the hash function is used to apply is used and applied to each element in the list. We apply the hash function. Now, what kind of hash function we apply? So some kind of an hash function which generates a key value. Okay, we'll look into that. The result of this hash function is placed into an address in the table that represents the key. Okay, so you're going to store that result what you obtain from the hash function as a key into the table. Okay, so linked lists are used as the address table for sorting the keys. If there are 4 keys, then 4 linked lists are used, or in other words it depends on the number of elements what you have to sort. Okay, so many linked lists have to be created. So hash function places the element in the linked list are called as subfiles. Okay, what hash function will do? So it's going to place the elements into the linked list. And how many such linked lists will be having? Will be having the number of linked list is equal to sometimes maximum is equal to the number of elements, and sometimes even lesser than that also. When we go to the example, you'll understand. Now, and each of those linked list is called as a subfile. Now, an item is placed into the subfile in the correct sequence by any sorting method. So again, if you want to place more than one element into the list, singly linked list, again we go for using the sorting technique. Any one of the sorting technique you can use. Okay, say for example, inside a singly linked list, how to insert, so you know how to insert at the front end, you know how to insert at the rear end, you know how to insert in between. So appropriately, if a singly linked list is going to contain more than one element, so then before inserting you got to do the comparison and you got to insert the element to the appropriate position. So that you'll understand when we go to the example. Okay, next. So procedure is this. So in this method, if a hash function is required, so and we call that hash function as f here, it is applied to each key. Okay, so the result of the function, hash function, determines into which of the several subfiles the record is to be placed or the item is to be placed. So once you make the call to the hash function, so on the key it will tell you where that element needs to be placed inside the subfile, or which subfile the element needs to be placed. So that is going to be decided by the hash function that we call. Okay, and one property the hash function should have is, if I say the element x is less than or equal to y, even when I apply the hash function on that element, the result what I get out of this hash function should also be less than or equal to the hash function of the other element. If I say the element x is less than or equal to the element y, even after applying the hash function on x and y, the same property should hold good. Okay, so that means that such functions are called as order preserving functions. So the hash function should have this property, order preserving function. So an item placed into SF file in correct sequence by using the sorting method. So if in case if SF file is going to contain, or if you are mapping too many elements onto the sub file, then every time you are mapping, you should go for arranging it into some sequence, correct sequence, by using some kind of a sorting method. Any sorting method you can go for using. Okay. After all the elements are placed into the sub file, the list of files, or you can say the list, multiple list what we are going to get, are concatenated to produce the sorted list. So from the beginning we go for concatenating these lists and finally build one complete sorted list. Now how it works, so with this example you'll understand. So all the doubts which you might have in this part, so it will be cleared here. So this is what the unsorted array we are taking. Unsorted array. So it has 10. So let us create this 10 subfiles. Why 10 subfiles? You can say 1, 2, 3, 4, 5, 6, 7, 8. But I am creating 2 more extra. Okay. So always you go for creating the subfiles, and it should be more than this. Okay. So sometimes we may not will not go for using all of that, but to be in a safer side, what we do, we always go for creating the number of subfiles at the linked list, which is always greater than the total number of elements. And initially when you create the linked list, see, I am going to have a 10 linked list now. So and this is 0th linked list, first linked list, second, third, fourth, fifth, sixth, seventh, and this is what I call them as the key now. Okay. Initially each list is empty. Next what I do, now I take these are my elements, unsorted elements. Okay, this is what is my array. So 25, 57, 48, 37, 12, 92, 86, 33. Now what I do, so the number, each of the number which is there in my unsorted array is passed to the hash function. I pass it to the hash function, and what the hash function is going to do here is it's going to return its last digit. So in this case, since we have taken all numbers with 2 digits, it's going to return you the digit which is there in the 10th place, or the 10th place, so which is placed at the position only in the linked list. Say for example 25. So when I apply the hash function for this 25, so this hash function you have to implement in such a way that it gives you the digit which is present in the 10th position. Now what it is giving me is 2. Okay. Now and it also satisfies this property. I'll tell you this property which I mentioned earlier. So if the element is less than or equal to y, so the result of the hash function on those elements is also less than or equal to y. So this condition is satisfied. So and it has to be satisfied, and that is true here. Say 25, what I am taking, and another one is 57. So 25 is less than or equal to 57. So this condition is true. Now when I apply the hash function, which is going to return you the digit which is stored at the 10th position, now I am getting it as 2. So the result of the hash function on this 25 is 2, and again that is less than or equal to the result of the hash function which is applied on 57, that is 5. So 2 is again less than or equal to 5. Now the hash function which I have taken is satisfying the condition that was that has to be satisfied by the address calculation sort. Hope you people understood till here?
Yes, sir.
Okay. So hash function of 25 is 2. So that means you have to go for writing this hash function in such a way that it gives you the digit which is stored at the 10th position. Okay, 10th position. And next, hash function of 57 is 5, no doubt. hash function of 48 is 4, so 37 is 3, and for all these things this condition is satisfied. Okay, so similarly 12 is 1, 92 is 9, 86 is 8, and 33 is gives you 3. And we have already the keys, we have already taken the keys from 0 to 9. Now since the number 25, on the element 25, when I applied the hash function, it is giving you the result 2. Now I understood that this function, this element 25 should be attached to the linked list or the subfile which is having the value 2. So see, you can see this is the subfile or the linked list which is having the value 2. There I am attaching it. So I have this 25 inserted to the list 2, and this is a null element, null. So this is the info field and this is the next field. OP people are following?
Yes, sir.
So only thing is the next field is not shown here. Correct, right? Yeah. And then f of 57, okay, it's giving me 5. That means I understood the 57 should attach, must be attached to the singly linked list which is having the key 5. Okay, so to 5 we are attaching 57. So this is as the info field, and the next field is the null field. Okay, so we have attached this, and then I apply the hash function on 48. What it is giving me is 4. Now I understood it has to be attached to the singly linked list with the key 4. Okay, next is 3. So on 37, the hash function is giving you the value 3. Now this 37 should be attached to 3. You can see here 37 is attached, and here there is a next field. Okay, and next is 12. So on 12 the hash function is giving you 1. So you can see the 12 is attached to the list which is having the key as 1, and this is the null. So this is done, this is done. Next what we have is 92. So 92, on 92 as value is giving you 9. So 92 is attached to the key 9. Okay, and this is the next field which is initialized to null. Okay. And next is 86. See, attached here. On 86 the hash function is giving you the value 8, so it is attached here. And finally 33 gives you 3. You can see here. So when I come to 33, it should be again attached to the list which is there with the key value 3, and to this 37 was already attached. So this was the first thing that was attached. Now 33 we are coming. So 33, so this list 3 already has an element 37. Okay, and it is storing the null value. So now I have to go for inserting same 33, that's another element 33, to the list with the key 3. Now since it has already has one element with the info field 37, I have to go for comparing and do the necessary comparison and find out the position where this new element has to be inserted. The new element here is nothing but 33 has to be inserted. Since 33 is lesser than 37, I have to go for performing the front insertion to this particular singly linked list. And you know how to do the front insertion. So in the next field of the new node, that is 33, you got to store the address of this 37 node. Okay, and that's all. Once you do that, and the address of 33 has to be stored in the link field of this particular thing. This acts as the header node which is holding the key value, or it says it's the list 3. Okay, and after doing all these things, so now to short, you're going to concatenate all these subfiles or all these linked list, to get the original shorted list. So 12, you got to take this list, concatenate that with this 12, 25, and that 12, 25 list has to be concatenated with the list 3, list with the key 3, 12, 25, 33, 37, you get it. And then to that you got to concatenate 48, then 57, 86, 92. So finally when you go for concatenating them from the lower key to the higher key, so you get the shorted array. Hope you people understood.
Yes, sir.
Okay, so this is easier. Say for example, if you have a 3-digit number, then you got to go for writing an hash function such that it gives you the digit which is there at the 100th position. Okay. So after fully completing, this is what the shorted array, you'll get it. Okay. So I'll give you one more example and try to solve it by using the address calculation sort. So we'll solve one more example and then we will go to the implementation part. Yeah, take these things. So 12, 10, 0, 5, 15, 26, 22, 55, 98, 21, 54, and then 86. Yeah, try to sort them by using the address calculation sort. So first thing, you have to go for finding the hash value of all these elements, and before that you have to write the subfiles. Okay, so how many elements we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'll go for taking I'll start from 0, 1, 2, 3, 4. I'll go till 11, 5. So it's not required actually, because 2 or more elements gets merged to one single list. 6, 7, 8. Since I have 9, I have to the 9. Okay, the maximum is 9. I have to go till 9. 9. Okay, enough I think. Next. So I'll write the hash value here for each of this element. So f of 12 is equal to 1. That means now I understood. So 1 gets attached to the subfile or the list with the key value as 1. So 12. Hope you have followed.
Yes, sir.
Next,
Yes, sir.
second element we take f of 10. So what I'm getting is 1 again. Now this also should go into the linked list with the key value 1. So but we have already one element attached here. Now I have to go for comparing this new element 10 with this. So 10 is less than this. So I have to go for performing the insert front operation. In case if the new element is bigger than the element which is already existing here, I have to go for performing the rear insertion. Okay. Now what I'll do, I'll erase this and write 10 as the first node and 12 as the second node. So 10 is the first node, and then we have 12. And this is null. Okay. Next is 0, 5. So f of 0, 5. So the 10th position we have 0. That means this node should get inserted to the linked list with the key value 0. 5 is attached here and this is null. Next I take 15. F of 15 is giving you 1, and again this should also go into the linked list of the sub file with the key value 1. Now I take this 15, I keep comparing. I compare just with 10. 15 is greater than 10. So I travel to the next node and I can compare with 12. So 15 is also greater than 12. Now it has to be inserted towards the right side of 12. I'm inserting it towards the right. I'm inserting it towards the right side of 12. And this is null. Next is 26. So f of 26 is equal to 2. Now this 26 should go into the subfile or the linked list with the key value 2, 26, and this is null. Next is 22. So f of 22 is also equal to 2. Again this should also go into the list with the key value 2. So we have already 26 present here. I go for this is the new element which I need to insert to the linked list with the key value 2. Now 22 is lesser than 26. I do this comparison and then I erase this. Let me erase this also. So 22 goes here, gets inserted. Insert front will happen. 22 and then the node 26. And this is null. Okay. Next is 55. F of 55 is 5. Okay. So it gets attached here. So 55 and this is null. And next what we have is 98. Okay. F of 98 is equal to 9. Now it gets inserted here. $98 and this is null. And then f of 21 again is equal to 2. It goes to this. So in this I have already 22 and 26, but 21 is less than 22, so I have to go for performing insert front operation. 21 here, and then 22 here, and this also have to erase. Finally 26. So insert front operation is performed, and this is null. So after 21 we have 54. So I'll find the hash value for 54. I'm getting it as 5. This 5 also, 54 gets inserted again to the list which is having the key value 5. So this is 55. So 54 should be inserted before 55. So insert front operation we have to do. 54, and then 55. And this is null. And the last one is 86. So f of 86 is equal to 8. So we have it attached here to the linked list with the key value 8. Next, to sort them, we go for concatenating all this singly linked list. Okay, we start from the singly linked list with the key value 0. So when I concatenate, I don't write it in the form of the list. What you have to do is you have to start from here. Instead of storing null over here, you have to store the address of this node. Okay, so address of this node, if you store here, so there's a pointer from here to here. Or other words, let me write it directly. 5, 10, so 12, 15, 21, 22, 26, 54, 55, 86, and 98. So this is the first list which is concatenated with the second list. This is the second, till here it is the second list. This is the third list. This is the fourth list. This is fifth, and finally this is sixth. When you concatenate or merge all this list, you get the shorted array. So this is how the address calculation sorting works. Okay, so with this, now we'll go to the implementation part. Clear, right? Understood now?
Yes, sir.
Okay. So now sorting techniques, implementation. Okay. So we'll start with the first one because when we discussed the sorting techniques, the first sorting technique that we understood was the bubble sort technique. We'll start from here. So let me start from the main program. Yes, so main is starting from here. Let me close this. Okay. Say I have taken the array. So this is my unsorted array now. What I'm doing here is, I'm finding the size of the array. How to find the size of the array? See, size of array I'm computing. Okay. So total size of this array divided by size of an element. So each one is an integer here. Total size of the array divided by the size of the integer will give you the number of elements. OP people understood? Is this clear? So if I assume, so size of integer is 2 bytes. How many elements I have here? 1, 2, 3, 4, 5, 6, 7 elements I have. Okay. 7 into 2, 14. This will be 14. Okay. Divided by size of array of 0, this element, 2 bytes. 14 by 2, how much you'll get? 7. So this is the easiest way of finding what the size of the array or the length of the array. So here I'm not reading the array from the keyboard, instead I'm just hard coding it in the program. So this is the direct initialization of the array. So after finding the size of the array, I'm calling bubble sort by passing the array and n, the number of elements. This entire array I'm passing, and also the size of the array, that is n is 7. So both of them I'm passing. Now we'll go to the bubble sort function. So here is the bubble sort function. Okay. Now as I explained to you people while explaining the logic of the bubble sort, I told that there will be 2 for loops here. One for the number of passes and one for the comparisons in each pass. Okay. And you also know, if there are n elements, you require n minus 1 passes, and the number of comparisons required in each pass will reduce by 1. Okay, because why it reduces by 1? Because at the end of the pass 1, the biggest element gets placed in its proper position. So for that reason, so the outer for loop, if you observe, I is equal to 0, I less than n minus 1. Why n minus 1? Because the number of passes is required. Passes required is 1 less than the number of elements. Okay, so n is the total number of elements. So in this case, it is 7 elements here, but the number of passes required is 7 minus 1, that is 6. So that means I want the outer for loop to iterate for how many times? 6 times. And then j is equal to 0. So in the inner for loop, what you observe is j is equal to 0, j less than n minus I minus 1. Now why we are doing this minus I also is because on every pass the number of comparison required decreases by 1. In the first pass, you require, if there are 7 elements in the first pass, you require 6 comparisons. In the second pass, you require only 5 comparisons. Third pass, you require only 4 comparisons. So that is the reason we are writing this. And next, what I do, I go for comparing the first element with the second element. Okay, I'm just checking if the first element is bigger than the second element. If the first element is bigger than the second element, then it requires a swap. Okay, I make a call to the function swap by passing the address of first element and also the address of the second element. So or else if you want, you can do it here itself. You can open the curly braces and you can go for exchanging here itself. So but I'm using the swap function here, calling one more swap function. Understood till here?
Yes, sir.
Okay. So swap address of first element in the array and address of the second element. Why do you say this is second element? Because j plus 1 you are writing. If j is 0, so array of 0 is the first element, array of 0 plus 1 is the second element. Okay, so first element and second element. Let me go to swap. So now since we are passing the address, so I have the pointer. Say the xp is the first element, so yp is the second element. Now what I'm doing, so first element I'm copying it to temp, and then the second element I'm copying it to as the first element, and the value first element which is available inside the temp I'm copying it to yp. Say for example here, say let me take the element to short of 5 and 3. 5 and 3, this is the first element and this is the second element. So xp is this and yp is this. What I have to do now, I have to exchange them. This 3 I have to write in the place of 5 and 5 I have to write in the place of 3. Now if I write it go directly, so without taking the backup, what will happen? Say for example I want to take this 3 to this position. If I overwrite 5 with 3, so 5 I will be losing permanently. For that reason what we are doing, so to temporary variable I'm backing up the element 5. So temp is equal to 5 now. So temp is equal to 5 and then xp is equal to yp. So what is that I'm doing? I'm overwriting this 5 by 3. It's 3 and then this one instead of 3 I have to make it as 5, and 5 I've already backed up it to the temporary variable. From the temporary variable I assign it to yp. So this 3 now becomes 5. Hope you understood. Yeah, this is what is swapping. And in the next iteration what happens, j is incremented by 1 So j becomes 1. That means j is holding the index of this 5, and say the next number is 6 now. Okay, so array of j, that is 1 5 greater than array of j plus 1, 1 plus 1 2, 6. 5 is greater than 6. Condition is false, we don't go for swapping. That means 5 is already smaller than 6, no need to swap. Okay, so this is how we go for sorting. So I hope this is the logic of bubble sort, and this is what we understood in the earlier class with the examples. Okay, and after that, so after it is sorted, so you call bubble sort. So here basically the array gets sorted. Okay, and then what's happening, you say sorted array, and to print it you are making a call to print array. So if I come to this print array, so I'm running a for loop here, easy one, is equal to 0 to I less than and I plus plus. I'm printing the elements of the array which are in the sorted fashion. So hope it is clear. Any doubts in this? Okay, so this is the implementation part for the bubble sort. So now and similarly we also looked into the selection sort. Okay, now what we did in the selection sort, you people remember? See, in the bubble sort we do something like this, say 5 3 2 1 0. Now we compare these two. Okay, and then if the first element is bigger than the second element, we exchange 3 5 2 1 0, and the next we compare the second and the third element like this. But in selection sort, what we do, we take the first element and we keep comparing that element with the rest all elements. Okay, that is what is the selection sort. Okay. Now main again, now here we are using I and j for loop counters. Okay, they act as the variables for the for loop counter, and the variable temp is used for the swapping. So count for the total number of elements. So the variable count is going to hold the total number of elements, and number to store the array inputs. Number array is the name of the array which holds all your unsorted elements. You can increase or decrease the size of the number array as per the requirement. Okay, so now in this program we have set it to 25. If you want to add more elements, then you can go for increasing. So these are the variables. Okay, you understood now why these variables are used. Now we read the number, okay, of elements, and that is going to the count. Normally we used to take it as n, but here it is taken as count. So and then after reading the total number of elements required, I go for reading the elements. Okay, so enter so many elements, and looping through the for loop, and reading the elements from the keyboard and storing it into the number array. Okay, next what we are doing, see, so logic of selection sort algorithm. First I start here. So the outer for loop, I is equal to 0, I less than count I plus plus. Now inner for loop you just observe, j is equal to I plus 1. So something like this. Say for example I have 5 4. So these are the elements I want to sort, 3 2 1. Now I have to take this 5 and I have to go for comparing this 5 with the rest all other elements. Okay, so now I value is, this is at the index value 0, this is at index value 1, index value 2, index of this particular element is 3, index of this particular element is 4. Okay, what we are doing is I is equal to 0 initially, and j is equal to I plus 1. So I is 0. Since I is 0, 0 plus 1 is 1. That means j is holding the index of the first element, and I is holding the index of the first element, and j is holding the index of the second element. Now I can go for comparing. So here number of I greater than number of j. Number of I is nothing but 5, and number of j is nothing but 4. I am checking whether 5 is greater than 4. Yes, true. Now you require a swap. What we are doing, we are swapping here. So I'm assigning number of I, that is number of 0, to temp. So temp gets 5. Temp is equal to 5. So temp gets the value 5. Now I go for writing number of I, number of 0 is equal to number of j. So number of j is 4, and that is going to overwrite the value which is present at the index value 0. So 5 is the value, current value, and it gets updated as 4. And now number of j, I'm going to assign the temp value. Temp I have 5, and it gets assigned here. Correct, right? So what I did now, in the first iteration of the inner for loop, I compared 5 with 4. Okay. Next, what I do? Next, again we go back to this inner for loop. J gets incremented by 1 more. So j becomes 2. What is the value of I? Still 0. That means I'm comparing this 4 with 3 now. Hope you following? So comparing 4 with 3. So again I check 4 with 3. So 4 is still greater than 3. So it requires a swap. So 4 comes here and 3 comes here. Excuse me. So 4 and 3 they got exchanged, and again in the next iteration of the inner for loop, j becomes 3. Okay. Again I value is still 0. So what we are doing now, we are taking 3 and we are comparing that with 2. Okay. So it's still 3 is greater than 2. Swap is required. So 3 comes here and 2 comes to this place. Okay. Next, in the next iteration, j becomes again 4, incremented and 4. Now what we are doing, we are comparing 2 with 1. So 2 is still greater than 1. Now again swap is required. 2 comes to this position and 1 comes to this position. So at the end of the pass 1, what is happening? So the smallest element is placed in its proper position. Okay. So the at the end of the pass 1, this is what the status: 1, 5, 4, 3, 2. Okay. Next, what we do? So we go back. So since j gets incremented and it becomes 5. Now when you check, so 5 less than or equal to count, it's false. 5 less than 5 is false. So we go back to the outer for loop and I gets incremented by 1. It is 1. Next, what we do, we go for taking this element, second element. Okay. And we keep comparing that with all the other elements, something like this. Okay. Is it clear? Okay. So this is what this program of so it is hanging. 1 second. Yeah, program of the selection sort. Okay. So this is easy. Okay. So the bubble sort and the selection sort, you understood how it works. And then what we do? Yeah. Now after this we are printing. So earlier in the previous program we were calling a separate function to print the elements of the array, but now we have written it inside the main program itself. Okay. Shall I proceed to the next one? So if you have any queries or the doubts, you can ask me here. Okay, thank you. So next one is the insertion sort. I hope all of you remember how insertion sort works. You remember, right? Okay. Now how it works? So how it works, or do you want me to show it once and continue with the program? Once I'll I'll show you. So quick sort, and it was here only. Yeah, insertion short. Okay, not this. Let me check this insertion short. So insertion short basically works with the shifting. Okay, I'll show you. So you got to do the shifting operations here. It's not opening. I don't know why it's not. Yeah, I got opened. Okay. One second. Let me go to the insertion. Oh, this is the other one. Shorting techniques. I think I had it here only. Yeah, this is insertion short. So I'm not able to move it. Okay, see, here is this. So in insertion short, elements are compared and inserted to the respective index place. Now what we do here, so it starts with comparison of first and 0th element in pass 1. In pass 2, the second element is compared with the 0th and the first element. In the pass 3, the third element is compared with the second, first and 0th element. And while we are doing this kind of comparison, what we do, so the elements in the list appropriate are inserted by shifting the elements on the right. So shifting operations you have to do. So we'll go to the example quickly. Yeah, here. So I hope you remember this. Okay. So 4 passes are required. Now what we are doing in the first pass, you're comparing the element at index 1 with the element which is indexed at index 0. Now this 75 is greater than 57. Now what we do now, I go for shifting. Before shifting, I copy this 57 to a temporary variable, and then I perform the shifting of the 75 from this position to this position. Okay. Now I shift it here, okay, and then I go for copying this 57 to this place. Hope you understood. So the last class I mentioned, this is what is the comparison you're doing, and this is what is the shifting you're doing. Is that clear? And in the next one, see, in the second pass you have the element which is at 0, 1, 2, second index. So we compare with both first and 0. Okay. Now when I compare this 25 with 57, so 25 is smaller than 57. Now what I have to do, I have to go for copying this 25 to the temporary variable and then shift this 57 and 75 by one position towards the right. Okay, so I compare this 25, I copy it to the I copy it to the temporary variable. So 75 I'll shift here and 57 I'll shift to this, and then 25 will be returned to this position. Okay, so like this we'll go to the program now. Okay, let us start from the main program. So again same thing, I have this array, so hard-coded array taken inside defined inside the program itself, and this is how I'm finding the size of the array or the length of the array and making a call to insertion sort by passing array and n. Okay, so this entire array I'm passing and also passing the variable length of the array, that is n. We'll go to the function insertion sort. So insertion sort, so you can just observe here. So for I is equal to 1, I less than and I plus plus, I'm starting from 1. Okay, now why I'm starting from 1? So why not starting from 0? Because I have to take the element which is at first index, and I have to compare that with the element which is at the 0th index. Okay, so if I just open this and show you, so what I'm doing now, I'm comparing the element which is at the first index with the element which is at the 0th index in the pass 1. In the pass 2, I go for comparing the element which is at the index 2 with the elements which are at the index 0 and 1. Okay, so same thing. That is the reason we are starting here. We are starting I from 1. So we are not starting I from 0. Now what I do, I go for assigning array of I, that is array of 1, the element which is stored at the index 1 as the key. Okay, and j I am initializing with I minus 1. So key is the element which is stored at the index value 1, and what about j? J is holding the index value 0, because I is 1, 1 minus 1 is 0. J is holding the index value 0. So j, let me write here, j is equal to 0, and key, if you want I can take this example itself. So 75, 57, let me write down 75, 57, 25, 19 and 4. So 75, 57 and then 25, 19, 4. See, key is this 57. Okay, and j is holding the index value of this. This is 0, index 1, index 2, index 3 and index 4. Okay, next. So we are comparing now here. So while j greater than or equal to 0, so j value is 0 right now, 0 equal to 0, true, and you're comparing array of j, so that is 75 greater than key 57. Yes, this is also true and this is also true. You're comparing these two basically, correct? Now what you have to do, you have to go for shifting. Now how you are shifting, you just observe here. So array of j plus 1 is equal to array of j. So j plus 1, so array of j is 75, you're writing the 75 to the place of what 57. Is that clear? Okay, so j is 0. 0 plus 1 is what? 1. This position. So to this position, what you are writing? Array of j. Array of j, how much here? 75. Now this 57 will be overwritten by 75. This is what the shifting. Okay. Next, j is equal to j minus 1. Okay. J is equal to j minus 1. Now the j value is 0. Okay. Now when I do 0 minus 1, j value becomes minus 1. When I subtract 1 from j, it becomes 1. When I go back to the while loop, I just check j is greater than equal to 0, minus 1 greater than or equal to 0. False it is, it will come out. And then what we are doing, observe now. So array of j plus 1. What is the current value of j? Minus 1. Minus 1 plus 1 is 0. So array of 0 is equal to key. What is the key value now? 57. Key was earlier pointing to 57. Key is holding 57 till now. Key value is 57. Now array of minus 1 plus 1, array of 0 is equal to 57. Now 57 comes to this position. Is it clear? Okay. So we proceed like this. Next, what we do? We take this 25, okay, and we compare that with 57. Again, 25 is lesser than 57. Now what we do? So this 25 gets copied to key. So 25 gets copied to key, and then we go for shifting the 75 from this place to this place, 75. So in this case, in the second pass, so this while loop is going to iterate for 2 times, okay, and in the second iteration, this 57 we will overwrite this 75. So 57 again comes to this position, and we have 25 written here. Now when the control comes out of the while loop, when the control comes out of this while loop, we have array of j plus 1 is equal to key. So it gets written over here. Understood now? Yeah, it goes like this. I think so we have done 3 program implementation we understood now. Bubble sort, selection sort, and insertion sort, and the next thing is the quick sort. Okay, so this implementation we will discuss in the tomorrow's class. Quick sort and merge sort, and then the radic sort, and then one more address calculation. Still we need to discuss the implementation part for the 4 more programs. Tomorrow we will try to complete all the 4, and in the next class, that is on Saturday, we will start with the searching techniques. I'll finish it soon within half an hour, and after that we are going to start the hashing techniques. Okay, so after hashing techniques, so there is one more topic on the files. If these 2 if I complete, so the entire syllabus is done. Okay, so I'm hoping to complete this entire thing in the next week. By Saturday I'll be winding up everything. Okay, along with the lab program, that last 12th lab program which is remaining. So now we'll stop here.